We've got a lot of stuff to cover today. We have an exam coming up a week from today. Is that right? Next Tuesday, I think it is. So I'll try to give you a few comments about that at the end of class today. But before we do that, we're going to review some of the basics of kinetic energy and free fall and gravitational potential energy. And then we're going to tackle the brain burner from homework 5, just so you know exactly how to do it. All right. And we have an example from homework 5 that we'll actually do. And then we'll talk about a little bit more about what gravitational potential energy is, how it's used, and we'll work out a deluxe problem from the space shuttle with rounded off numbers and simplified calculations that will hopefully make some sense to you by the end of class. So SI schedule, and also there was office hours with Anna on Friday, and I know she had some people come. Next one for you guys is Wednesday. Question in the back. It doesn't say exam 2 what? March 30th. Okay, so that's the week after. Okay, so we got 2 weeks to go. Good. That means even more homework before exam 2. Nice. Anyway, so but it's coming up, and I'll talk a little bit about it, hopefully at the end of the lecture. Have your clickers ready. We're going to work out some more kinetic energy examples here, concepts, and then we're going to tackle the brain burner from homework 5. And just to remind you, to reinforce, when you're doing a calculation problem inside web courses, where you have to type in a number of joules, a number of meter per second, anything like that, a number of meters, every attempt that you have on that quiz, like 4 attempts or sometimes 7 attempts, every time web courses will generate at least one new random number in there. So your calculations from your first attempt, you can't recycle on your second attempt. Okay, so you have to read carefully and recalculate and hopefully get it right as you use it for a study tool. Now, kinetic energy examples. Let's talk about a frozen chicken falling out of the skies. Let's just say that the mass of this frozen chicken is 2.6 kilograms. Write that down because you're going to need it for your first clicker question. And let's say that it's moving to the right. All right. And that its initial speed is 12 meters per second. So that would be V subscript I, initial speed. And it's rightward, so we know the direction of it as well. All right. And let's calculate, first of all, the kinetic energy. Okay, just to reinforce. Now, the main formula for that, the generic formula, is 1/2 mv squared. And so what you do is you plug in the numbers that you have, 0.5, 2.6 kilograms for the mass of the chicken, and then 12 meters per second quantity squared. So that's v squared. Now, you can't forget to square that baby. All right. So we're just going to go through it step by step. And this stuff is going to seem really easy by the time we get to exam 2. Hopefully it'll be really easy by the end of today. All right, so next thing you do, there's your plug-in step. All right, now you got to do a little bit of calculation. And what I always do, if I can, if it's easy to do mentally, I put the 0.5 and the mass together into, like for this example, 1.3 kilograms. All right. And then for the square, v squared, I square the number and I square, so here's squaring the number. Right here, 144, 12 squared is 144. But you also have to square the units. Meter per second squared, quantity squared is meter squared per second squared. So meter squared on the top and second squared on the bottom. Now, don't forget that. All right. And so the result is now you multiply 1.3 times 1.44, or excuse me, 144. Anybody verify me 187.2? Okay. How about you guys over here on the right? I can hear you talking over there. You got to calculate it? All right. So there's your calculation. Now, you're going to do, because I can hear you all the way from here, so it's halfway across the room. All right? So try not to talk over me. All right? There's students that are working their, you know what, off in here to get a good grade, and a lot of students are really worried. So the less distraction that you can generate, the better. Okay? I've already eyeballed you twice today. Right? If I have to yell at you again, then you're going to be in big trouble. Right? So try to hush up for the next 45 minutes, 50 minutes. All right, let's keep going. Don't laugh, man. I'm serious. I saw you laughing. As soon as I looked away, you started laughing. It's not funny. There's kids in here that got to get through this. And they're going to be hustling and busting their butt. If you don't want if you don't have to work hard to get an A or a B or whatever you want, there's other students in here that are busting their butt to get a C maybe. So you laughing at me, that means you're laughing at them. And I don't like that. I don't want to ever see that. Because what happens if I have to laugh at you? How about that? That would be considered extremely cruel. So I don't want to ever see you guys doing that. All right, so there's your calculation. Let's do a clicker question with a final speed of 8.4. So let's slow it down a little bit. Now, we're not talking about what the force is, but, maybe a little friction or something. And eventually, after a short amount of time, short amount of distance, slows it down to 8.4. Okay, so it loses about 3.6 meters per second of its speed. All right. So your calculation. First question for today. Multiple choice. Calculate the final kinetic energy at speed Vf equals 8.4. And we'll go over this one step by step. So do your best. Take a minute or two. Now you can talk with your neighbors and stuff and kibitz and whatnot. Coordinate and counsel and get ideas. And don't forget, there's one seat up here open right next to Anna, the TA. So if you feel like you're a little bit nervous, just come up here at the beginning of class and just study with them, and they can help you on calculations and anything else. Two point six, 8.4, 3.6. Oops. Okay, I accidentally clicked that question closed. Hit the refresh key, do it again. Make your choice, and if you haven't made your choice, you could just type it in again. Everybody type in your answer. I want to look at these things here. Yeah, same chicken.
And they seem that they were just switching out kilometers per second for each one from the original equation.
Where's my phone? Got a lot of good brain waves going on up here. Very good. That's what we want. Okay, 30 seconds starting right now.
So that's the next question.
20 seconds. Hurry up, we're doing a quick question. We got some more, so don't worry. You missed this one. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, let's see what you guys voted for here. Let's work this over. Yeah, option D is the correct answer. And it looks like 86% of you got it correct. So that is really nice. But just for safety, let's work it out. Here's your plug-in step. You take the generic formula, K equals 1/2 mv squared. And in this case, it's v subscript f squared, just for a little extra information. And that works. And so then again, we have 0.5 and 2.6. Now we know what's going to happen to those. It's going to turn into a 1.3. But now we have 8.4 meters per second quantity squared in parentheses. Now we're going to do a little bit of special handling for this. So we've got the 1.3. Ding, that's basic. 8.4 squared is 70.6. All right, and that's from this the fact that you're squaring this entire quantity. Now that also means that you're squaring meters per second. So that is how you get meters squared per second squared inside the parentheses. All right. So now you just multiply it out. All right. And let me just remind you that 91.728 kilogram meter squared per second squared, that's a joule. That's a number of joules. That's 91.728 joules. But it's expressed in kilograms, meters, and seconds. In fact, kilogram meter squared per second squared, that's equivalent to 1 joule. Now, I also have listed here right next to that 91.728 Newton meters. Do not talk over me. It's always over here. It's right over here, you guys. You guys in the 5th row. All right? Not the guys behind you. I already yelled at them. So when you're doing a calculation, sometimes it's good to express your energy in Newton meters. Okay? Because sometimes you might want to cancel out meters in the other half of your equation. Okay, so if you're If your energy is expressed as a number of Newton meters, ding, it's easy to. Sometimes the other side of the equation, you might have kilograms that you want to cancel out. Then you use the very first one, kilogram meter squared per second squared. All right. So keep that in mind. Now we're going to keep working on stuff. And when we do the brain burner together, I'm going to keep my kinetic energy here to finalize the brain burner. You have to get kinetic energy. And then when I do, I'm going to keep it as kilogram meter squared per second squared. All right. Now, let's look at some more clicker questions. Energy levels in Earth's gravitational field. Okay, so some more clicking. And let's look at a set of distances here. Go ahead and make a sketch, a y-axis, and we're going to drop that. You know, this is the actual mass of a basketball. The one in the homework was 0.800 kilograms. For some reason, when I wrote that question a few years ago, I looked it up and I thought I read that it was 0.800 kilograms for a basketball, but it's actually 0.62. So this one's a little bit newer. We're gonna use 0.62, but on the brain burner we're gonna use 0.8, just like the homework. All right. So let's work out some of the energy specs for this 0.620 kilogram basketball. First of all, you know, one of the things, you know, work is a force times a delta something, some kind of a change in position. Okay, so one of the things you want to get is sometimes figure out the force. So let's figure out the force on the basketball. Okay, and then we're going to calculate the work through a drop of 18 meters. Now, look at that information up there that I've written in. And I say delta y equals negative 18 meters, and I call that a drop. Now, what in that expression tells you that the basketball is dropping? Right, I see a lot of hands, the negative. So when the y coordinate gets smaller, delta y is negative, all right? And so that means it's dropping, all right? So we got to drop. So that means we're going to gain some kinetic energy. We're going to lose some potential. But let's just, so you have a corresponding delta KE, all right? So there's a change in the potential, there's a change in the kinetic, and let's think it over now. All right, so those are some of the main things. When you're working out a brain burner, these are the kind of things you got to step by step work your way through, all right? And then put it all together to get the brain burner, all right? So let's work on the very first concept, the weight force. What is the weight force of a 0.620 kilogram basketball? And actually, if you look at that one carefully, you'd be able to see it without even calculating it. Because in the metric system, the acceleration due to gravity, g, is pretty close to a 10. And that's easy to multiply by any other number. Good, good, good. Good, good, good. Yeah, how many newtons downward?
So in future examples, if there were an example with the same two numbers of the correct answer, but not upward or downward, we would be saying downward in this situation because gravity.
Gravity's always downward. That's correct. Yeah. So if I gave you, some number of newtons upward,
Right.
you'd know automatically cancel that one out. Don't even answer that one. Like the strategy, test taking strategy, eliminate, if possible, one or two,
Yeah.
and then maybe make a guess, educated guess on the others.
If we have an upward force that cancels out the number of powers of the downward force, would that be a reason to say?
Yeah. If you have somebody lifting, like Arnold lifting a weight. If in order for the weight to go up, he's got to push with a little bit more than the force of gravity. So if you have 100 newtons of weight, you need 101 to get it up there with a little bit of motion. 102, 200, and you're really, So for Arnold, that's 10 kilograms. It's 20 pounds. That's his little finger. Okay, 20 seconds to vote. 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, let's see. Yeah, 6.076, and it looks like 93% of you got that one. All right, so that's pretty boring. In other words, you guys know it. You've learned something. And just as I was saying, in the metric system, it's easy to get a weight force because G is approximately 10. So whatever the mass is, just multiply that by 10. So 0.62 times 10 is about 6.2 or so, and the only thing close to that is B. All right. So even if you had to guess and you don't have a calculator, you don't have time to do calculation on pencil and paper, you can still guess B, and you'll be on the money. And hey, you guys, just so you know, I usually say this before the first test, but usually I don't put trick questions on exams. I like putting tough questions, one or two, and I think that's fair. But a trick question here would be 6.074 newtons downward. That would be, that's not the kind of thing. Now, maybe in one of my other classes, I would grade it based on how close they are to the right thing. But for us guys, I'm always going to give you something that's clearly correct, so that if you can think of a few concepts, like 9.8 is close to 10, multiply that by the mass, you can, make an educated guess and get it right. Now, for the falling basketball, let's do a little vocabulary term here, because I use this term parallel and antiparallel. For a falling basketball, is delta y parallel or anti-parallel to the weight force? All right. And anti-parallel means, for when you're talking about vectors, it means that they're exactly the opposite direction. So a leftward vector and a rightward vector are anti-parallel. Versus two rightward vectors, those are parallel. Two leftward vectors, parallel. "30 seconds starting now." Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Let's see what you guys have got here. Um, yeah, 73% parallel. That's pretty good. Um, when they're when the force and the displacement, or the force and the velocity, are parallel, if they're in the same direction, that means you're going to speed up, and that's what happens when something falls. It gets faster and faster as it goes downward. On the other hand, if delta y is upward, so a positive delta y, and the weight force is still negatory downward, always, they're anti-parallel, and when that happens, a force and a velocity in opposite directions, you get slowed down. Okay, and that's what happens when you're moving upward. And the gravitation, you throw a baseball up, it slows down, comes to a stop, and then starts falling back down. And then its motion is downward, parallel to the force. All right. Which formula should you use to compute the work in this problem? Okay, type in an A, B, C, or D. And remember, work is always F, some force times a delta X, or some force times a delta Y if it's going up and down, or even delta Z if it's going in the Z direction. F delta Z. 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay. Let's take a look at this one. The spread in the answers, there's a little bit of centripetal. Now, the reason that this is not the case here is because we have a change in kinetic energy. Make a note of this. A centripetal force does not change the kinetic energy because it's always perpendicular to the velocity. And if you're perpendicular to the velocity, you're not making the velocity bigger, you're not making it shorter, you're not speeding it up, you're not slowing it down. You're just changing the direction if it's centripetal. So centripetal here is no go. All right? All right. So in this case, F delta Y is mg times delta y. That's the answer. All right. And in this formula, g is negative 9.8 meters per second squared. So you have negative, if you're falling, if delta y is negative, you have negative times negative, and so you have a positive amount of work. You've gained kinetic energy. Now hit the refresh key. We're going to do a calculation. All right? And we're going to try to put all this stuff together into a calculation. I'll give you a few minutes for this. All right, so the 0.62 kilogram basketball, and let's calculate the work done by gravity on the falling basketball for 18 meters of drop, of free fall. Okay, so take a minute to do that, and we'll go over the calculation for this when you're done. Okay. So if you wrote down the previous problem, always take notes on the clicker questions. Because now if you took notes on the previous question, you can do this calculation fast, fast, fast. Oh, you know what? I'm sorry, guys. Hold on. Let me stop that question. I'm going to have to delete that question. I want a numeric answer. So hit refresh and let's do it again. Okay, hit the refresh key, then type in the numbers the way it's set up there. To the nearest tenth of a joule of work, please. So something point something joules, and just type in the number, not the letter J for joules.
We're using the mass of
0.62 kilograms. 2.6, that was a frozen chicken. This one's 0.62.
0.62.
Yep. Yeah, don't confuse the basketball with the frozen chicken, man. It's never a good idea. And we just figured out mass times gravity. That's right. The midterm in here is 1 week before, the week before spring break. Good. No, they're both uppercase usually. So you just have to read from the context, know which one you're talking about. It's a pain, but we only have 26 letters, 52 if you count upper and lowercase. Raise your hand if you have your answer in. Okay, keep going, the rest of you. It's good. Okay, I see a few of you with answers to the nearest hundredth. Please double check your answer and type it in to the nearest tenth of a joule. Hey, you guys, is this thing getting faster as it drops 18 meters? Right, so the work done is going to be positive or negative? Positive, okay. You're gaining kinetic energy. Okay, 20 seconds to vote, starting now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. Let's take a look at the solution. Okay, so mg delta y, that's your work. And delta y is negative, and g is negative. What was it? Negative 6.0 something? Okay. So that's going to be a positive number. Here it is. Negative 6.076 newtons. That's mg, Andrew. Okay. And then the drop is, it's a negative delta y, so it's dropping. So negative 18 meters. And those two multiply out to 109.368, which in this problem is correct, 109.4 to the nearest tenth. Now, I saw this up here, and I told students, 3 students, they didn't listen. This one, I apologize. The decimal point on this iClicker is really hard to see. This one, see? And remember when I said, is it positive work or negative work? This student here, they typed in a negative. No, it's not negative. It's positive. So that one's wrong. All right, let's keep going. So, I'll get my cursor over here. So there's that calculation. Now we're going to do the brain burner. And so the question that I want to have you think about now is, can you figure out the change in the speed? And the answer, of course, is yes, you can. All right. The basketball gains kinetic energy, so GPE is less. It loses GPE. So whatever the kinetic energy gains, 109.4, the GPE loses. Okay, so delta GPE is negative 109.4. And they always add up to the same number, the total mechanical energy. All right, now we're ready to, well, let me pause for questions about anything that we've done so far.
What's total mechanical energy?
The sum of total mechanical energy is the sum of potential, GPE, and kinetic. And that number is always the same. The GPE can change, the kinetic energy can change, but the sum of them together, always the same. Yes, what is your name again? Melissa.
So -6.076, is that weight force or work?
That's the weight force. The work is, and they both use the same symbol, capital W. So you have to be careful when you're doing these. Read carefully and read for the context of what you're working with. All right. Now, we're going to go to the document camp, and we're going to take a look at this particular problem, which is, what is the, let's see, oh, this one is, what is the GPE at 2.0? All right. So we're going to go to the document camp and work out the brain burner that goes with that GPE question. So let me get up here, and I'm going to turn the lights up a little bit so you can make notes. Let's see if I can do this over here. Oh, let's see here. Anna, could you help me up here for a minute? All right, just come right over here. I'm going to need you to go. You have to hit this thing twice to get it to work. Okay, let's do the document. Could you give me my phone from over there? Thank you. All right, I'll use this for my calculator. And can you move your bag here? And I'm continuing to record this, but we're going to look at what I do in the document cam, and I'll embed this PDF in the in the YouTube, and hopefully that'll make sense to you. This is from my previous class. So let's do so this is PSC 1121. Could you give me my pencil bag from over there?
It's kind of bright.
Oh, okay. Thank you. Thank you. Let's try to get. Can you operate that? See if you can get it. Back it up. I need more space.
It should just autofocus. Oh, that's finally set.
That's no good. We need the light.
Yeah, I might have to turn on the lights.
All right, let's try that. You want to operate the lights then? I'll try to do this. Okay. Let's back this up first. Let's make this bigger. That's as big as we can get. All right, we'll try to make do with this. So this is 2, 18, 20. And this is the brain burner. Is that better?
It's better. It's higher quality.
You know, this is burning my grits here. Well, let's try it. Let's do what we can. Okay. Can you look up, do you have the problem there on the, who's got it on web courses? What's the top elevation on the web courses table? Was it 6? Okay, so Y, 6.00 meters. And then what's the next column? I want to try to make it look just like it's, is the next column GPE or KE?
GPE, so the position GPE, KE,
Okay, GPE, KE. And then, this is the total mechanical energy. So column 2 and column 3 always add up to this one, if you can figure it out. Now, I give you the potential energy here, what is it, 4704? Correct? Joules. And kinetic energy is 0.0 joules. Now, what that means is that it's at rest. Okay, and we're going to drop the basketball of mass equal to 0.800 kilograms. Now, and we're going to go down to any elevation that we want. So let me just write this down. And then here's the floor, 0.00 meters. And this one, now you've run out of potential energy. So this column, let me make columns here. My handwriting's a little bit messy, but this document cam is pretty nasty. And hey, you know what, you guys? You could write a V squared over here and then a V column if you have room. And we know what this one is, 0.0 meters per second, because it's at rest. That's easy. Potential energy is max, kinetic energy is min, 0.0 joules. So now, first thing you always want to try to do is figure out your at least one value of total mechanical energy. All right, and they allow you, or I allow you to do that two different places because I give you potential and kinetic at the bottom and at the top. So down here, this means that all your energy that was stored in the potential field between the basketball and the earth, it was 47.04 stored here. Now down here, it's 47.04 joules in kinetic energy. No more storage. You've used it all up. All right. So now the conservation of energy says that these two numbers always add up to the same number. So up here at the top, they add up to 4704 joules. And down here, 4704 joules. And guess what? You get 47.04 at 5 meters, 4 meters, 3 meters. So I'm just doing dittos all the way down here. Okay. And then at 0.00. Okay. Now, these two numbers are not going to be ditto marks. These two columns, no, they're changing. You know, you don't have any kinetic energy up here at 6 meters. You're just holding the ball. But by the time you get down here, you've accumulated quite a bit. Now, here's an interesting thing that you can do on a table like this. Because the potential energy depends on y, at the halfway value of y, the potential energy is at the halfway value of 4704. So what's 4704 divided by 2? 23.5. All right, so this is 20. This one's an easy one. And guess what? Where's the potential, the kinetic energy? 23.52. Same level. This is where you have 50-50 splits. All right, so you can do that all the way or anywhere that you have the halfway distance. And sometimes that's an important location to know. All right, but notice those two numbers as they must add up to 47.04. Now, what we want to do in the problem, the question was on one of the preliminary questions, what is the potential energy at 2.00 meters? Now, we already know how to do that. That's just mgy. And so this one, the mg is going to be a little different because this is the heavy basketball that we're using. All right. Boy, I wish this was clearer for you guys. So here's your. Let me change the light angle maybe. Ooh, that's better. Okay. Ah, I just turned. Nice one, Dr. B. There you go. I just inadvertently rested my hand and put it, turned it off. Good going. All right. So let me put my earpiece back in here. Hold on. Okay. So there's that. Now, what we want to do is the brain burner is find V at y equals 2.90 meters. Now, that's not the halfway point. And this is the number that web courses will generate a new version of this every time. So you might not have ever seen this. Some of you may have seen 2.90. So that's what we're going to figure out today. Now that's going to be somewhere up in here. All right, between 2 and 3, of course. So it's going to be a little bit more potential. So we might have like 24 point something joules of kinetic energy, or maybe 25. Let's calculate it out and let the numbers do the talking. All right. So in fact, I'll do this in red. I'll put the numbers for 2.9 in red, and that because I have an extra line there. So let's put in the special 2.90 meters. Okay, so there I've squeezed that in there. Now, if you can't squeeze it in, figure out some other way to record it. All right, first thing to do, GPE. That's equal to minus mgy, and we're just looking at the position y. So we're not really thinking about a delta y right now. All right, so minus mg delta, or minus mgy. So that's equal to minus 0.800 kilograms times negative 9.8 meters per second squared. And then my altitude, y equals 2.90 meters. All right, so let's do that on the calculator now. All right. So let's see if you guys can see this. Let me move this up a little bit. Okay, so 0.80 times 9.8. And you know, I'm dropping the minus signs because I've got negative times negative here, so it's going to be a positive anyways. Times 2.90. Okay, so there's my potential energy at 2.9736, or at 2.9 meters. So this is equal to 22.736 joules. And now I could put that number here, 22.736 joules at 2.9 meters. All right. Now, this number here in the kinetic energy column has to add with this to 4704. All right. So the kinetic energy, which we want to get, is equal to something. That's the next thing we got to figure out. But we know that kinetic energy plus GPE, gravitational potential energy, add up to 47.04 joules. And that is true at any altitude for this basketball. Okay? So now we could put in KE plus 22.736 joules equals 47.04 joules. And guess what? You can subtract those two numbers, and the leftovers will be your kinetic energy. So let's do that on the calculator. 47.04 minus 22.736, 24.304. Okay, so we'll subtract 22.736 joules from both sides. Okay, and that means that kinetic energy is equal to the leftovers, 24.304. Okay, and as I predicted when I was looking at the table here, I said, okay, this is between 2 and 3, so I'll probably have maybe 24, 25 joules of kinetic energy, and that's what it comes in at. So let's write that down now. 24.304. And let me put a decimal point down here, a better one. This is 24.304. All right. And of course, dittos. We also have dittos there. All right. Now we can go to the kinetic energy formula. Okay. Now we know what it is. So KE equals 1/2 mv squared. And that means that 24.304 joules is equal to 1/2, 0.5 times the mass, 0.800 kilograms times v squared. So we have everything in that equation there, right here, except for v squared. So if we do a little bit of algebra and calculation, we can get v squared by itself. And then when we do that, then we just hit the square root button, and that'll give us v. All right, so let's do, okay, this is the Cinci one here. So I have 24.304 joules equals 0.400 kilograms times v squared. Okay, so that's just putting my 1/2 and my m together. right in here. Okay. Now I have to divide both sides. What do I have to divide both sides by to get v squared by itself? Right. Divide both sides by 0.4. So I'll have v squared over here, and over here I'll have 24.304 joules and 0.4 kilograms, 0.400 kilograms, and that's equal to v squared. Now, before we do anything more with this, I'm going to change this quotient here, and I'm going to rewrite it over here, and I'm going to rewrite it this way. Now, watch what I do here. Instead of joules, I'm going to write this as 24.304 kilogram meters squared per second squared. Okay, that's my numerator. Because that's a joule. Kilogram meters squared per second squared, that's the same as a joule, right, by definition. Now, down here, I still have 0.400 kilograms. But notice we got some cancellation time. Kilograms get canceled top and bottom. But you can't cancel the top, everything. You still have meters squared per second squared. But that's all right, because you're looking for the square of a speed. All right? So let's do this calculation now. So v squared, I'll just write it over here. V squared equals, let me get my calculator back up. Okay, so I still have it, 24.304 divided by 0.400. Anybody verify me 23.904? Oh, I did? Oh, okay.
So it should be 60.7.
All right, let me try that again. 24, good. Okay, oh, this is divide by up here. No, wait a minute. Yeah, that's divide by. I'm getting a lot of glare here, so it's kind of, let's see, 0.400. Okay, 60.76. All right, so that's v squared. 60.76 meters squared per second squared. Don't forget that. Now, that's not your brain burner speed. That's the square of it. So now you turn your Apple iPhone sideways, and you get the square root key over here. That's way over here on the left. Okay, so the square root of 60.76 is, so this means that V is 7.7949, and to the nearest, actually, let me write this in over here, 60.76 meters squared per second squared, and this one is to the nearest hundredth, 7.79 meters per second. All right, up here in the table. So there's how you do it. Now I'm going to embed this. I'm going to not photocopy it, but scan it to a PDF. I'll put that in web courses. I'll also embed this in YouTube in the video. All right, and there's your answer. So let me put a red box around it to signify that's your answer. Okay? Now, let's go see if we got the right answer. All right, because, you never know. I might have dropped a digit here or something, so you got to check. Always check your answer. All right, let's go back to the laptop now. All right. So there's that. And I'll replace that logo there, or those diagrams, with the PDF of the work that we just did. Okay, so we're on. Can you gather up my materials over there and bring them back over here? All right. So the answer is 7.79, and if you don't believe me, just take a look at this. here's the problem that we just did. Now, this is the brain burner, right? Now, you can't, it's kind of hard to see, tiny letters. That's all right. I blew up this, there it is, and up there, 1 out of 1. So that means we got it. All right, so so this is how you do it. All right. Now, I want to talk to you some more. Well, let me pause for questions. Yes, Jennifer, Jessica, Cecilia, Melissa. Close. Okay. The unit, meters per second. But in web courses and iClicker, you never type in meters per second. You just give me the numeric part. All right. So this is it. Okay, another question before we continue. Now, my wonderful students, there's other ways to do this if you feel like it. You can use accelerations, drop distances, average, you can do all kinds of stuff, but this is pretty much the easiest way to do it. It does require a little bit of work, but it's the lowest amount of work of all the different ways that you can do it. Now, on all these things, when you're working with gravitational potential energy, it's important to set the baseline, at least have an idea of what your baseline elevation. So for us, it was the floor of the gym, y = 0, where the ball hits. And then you can calculate it to any height. And when you do that, if you set y = 0, then all your delta y's are just your y coordinate. Okay, so that makes it easy. But it's not possible to do that sometimes. Like if you throw something off a cliff, do you use y = 0 at the top of the cliff or the bottom of the cliff? If you're up in space, do you use y = 0 up on orbit or down at Kennedy? So there's different, but you always want to be able to at least say, all right, I'm going to choose y = 0 and then make a decision and stick with it. So like this guy, he's up there on the surface of the moon, this Apollo astronaut. He's about to jump down onto the surface. Can you imagine? He's got to be about 6-7 feet up off the surface. And he's loaded down with that big spacesuit and his backpack full of oxygen and stuff. And he's still going to jump. And that's what those guys can do that, because because the acceleration of gravity down there is about 1.6 meters per second squared. It's kind of pokey. So. Yeah, right. If you're scuba diving, you can do the same thing because you have buoyancy force. So it's equivalent to, and I think they train in scuba diving tanks and stuff, the astronauts. So if you know the kinetic energy at any level, like we did, the top of the motion, the bottom of the motion, or any intermediate height, which we just did 2.9 meters, then you can calculate total energy and then figure out every other thing about the dynamical state for any other level. So we started at 6.00, and we could have started at 0.00 elevation with only that information, and we still would have gotten, the key is to get that ditto column, the 47.04 total mechanical energy. Once you get that, you have any level that you want, as long as you know the mass. All right? So you get the GPE value, then you get the kinetic energy value, then you get the speed value, blah, 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 de blah. Okay? So on exam 2, before spring break, man, spring break is coming up. I already need a spring break. I needed a spring break about 3 weeks ago. Anyway, so when exam 2 comes up and you see a brain burner like this, hopefully I won't fry anybody's brains. Because I have a feeling you guys are starting to get the hang of this. Hey, maybe I'll give you a little bit of a homework assignment tonight. The Brain Burner Deluxe. You know what the Brain Burner Deluxe would be? The brain, see if you can do the brain burner. Oh, I got a bunch of really good ones. I even have one with Michael Jordan in it. The Space Jam. Yeah, from the Space Jam movie. All right, I'll try to get you guys a little tiny homework so you can really test your brain burning skills. See if your brain's fireproof. Okay. All right, let's talk a little bit more about potential. We're almost done. How about we break 4 minutes early today? And we'll start right here on Thursday. You're dismissed. Homework number 6 tonight or tomorrow morning, just 1 or 2 problems to test your minds, your so-called minds. Can you get the lights up to 100% power, please?